Hello everyone, my name is Xinze Xiang. Our group's subject is improved charging system for integrated solar charging electric vehicles. In recent years, with increasingly seriously environmental problems, traditional petrol-powered cars have caused a lot of air pollution, which has a great impact on life quality for humans. Also, high carbon emissions of traditional cars has caused great challenge. Therefore, electric cars are used on a large scale because of environmental friendliness. However, there is still carbon emissions in the process of charging electric cars, as most of the electricity is still generated by the force. This project focuses on an efficient PV charging connector to improve charging efficiency and reduce output, ripple to increase battery life. This project will solve the problem of the efficiency of charging, small scale distribute power generation, and the impact of high ripple charging on battery life. Integrated PV charging EVs can reduce the cost of using vehicles compared to conventional electric vehicles, as electricity price greatly rise. Integrated solar charging remains cheaper in the long run. It gives consumers a better option, besides by solving the battery life problem. We need to model the PV models using the MATLAB, as shown in pictures. A PV panels consist of hundreds or even thousands of PV cells, which can be simply simulated by current source. But since the output of PV cells is considerably influenced by temperature, sunlight, and shading, the output curve of PV panels is different with the geographic location. So we need to combine the typical light curve and the temperature curve of Sydney over a day with the character curve of the PV cells to get the typical output curve of the PV cells, which can be used to change the output of the current source. At the same time, a noise source needs to be introduced to simulate the impact of shading. We undertake this model design of a complete PV charger with the design and the selection of each component as follows. After the simulation, the output signal of the system can be obtained, which is the input power to charge the battery of the electric vehicle. The result of this project will be submitted to relevant journals such as IEEE. Besides, since the research focuses on EVs in Australia, it may also be submitted to the transportation departments and vehicle companies in Australia. Depending on limited time and funding, these projects only use software simulation for result validation instead of actual validation by building a real EV charging model. Because of the limitation of software, simulation data may far from actual data. The mistake is unknown unless the actual test. And that's all of my presentation. Thanks for your watching.